whereas a black surface absorbs all the color, and so 0 is reflected. And so that's where your RLI value comes from. Okay, it's reflected light into, it's what is reflected off the surface. So you'll see if your color sensor is facing down, you'll see it shines a little light, and that's the light that must then reflect off the surface, and that is measured by your sensor. You might have noticed, but you know, these sensors are electronics, and so I would hasten to add, you need to make sure that your team recognizes these as electronics. So they're not to be thrown around, they're not to be swung around on the wire, they're not to be chewed, they're not to be anything. It's electronics, and they are the most expensive components within your robotics kit. Replaceable, but at a cost. And so just FYI. Okay, so with your color sensor, you can detect the color, but you can also detect a line, and you can also follow a line. Detect a line, obviously the line mustn't be too thin, and you mustn't be traveling too fast. So if you've got a very thin line and you're traveling very fast, your robot is not going to find that line. Okay, so it must be detectable. All right, so it's detect is assuming that it's detectable. All right, follow the line. We follow the line on, and so if you stick down a piece of black insulation tape or any color insulation tape, what you're doing is following the edge of the insulation tape, ding, 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 and you follow the line. That's following the line. You can follow it around, you can follow a curvy line, you can follow it over intersections, but there's a trick to that. Okay, and then there's ambient light. Ambient light's the area around here. So there's a really cool one where you have a little cockroach and moving around it. And you know, when a cockroach, as soon as you put on the light, then it stops. Or does it flee? I'm not sure. I haven't seen a cockroach for a long time. But then, so then you can shine a light on the, and then the robot usually, if it's a cricket or a cricket makes a noise until you shine a light on it. So if your robot makes a noise until you shine a light, that's the ambient light. So if the ambient light suddenly increases, then the robot will stop. Okay, but that's a whole lot of projects, and then we're going to do that hopefully next term. Okay, so what you have to now is a single sensor. So it's single input. So you've got in the input process output system. Remember we spoke about a touch sensor, and then we spoke about an ultrasonic, and then we right at the end I said, well, what about if we put multiple sensors on a single robot? So then you understand, so the more information that you get from your environment, the cleverer your robot is. So now we've got a repetition and a decision-making structures, and we've got the sensors that are then providing the data. Okay. So now what we're doing is we're just adding color sensor now as another way of measuring the data. Okay. So about the color sensor, so there are different light measurements that can be made, and obviously the measurements that you make is what you're going to use it for. So are you going to measure the color of an object, or do you want to measure the ambient light around you, or do you want to measure the reflected light intensity? So that's the different types of light that you can measure. With reflected light intensity, you will need to calibrate your color sensor, and if you take in the ideal world between 0 and 100, your threshold value will then be 50. Okay, but when you calibrate a sensor, say for ultraviolet light or a natural light or sunlight, you would probably get not a 0, but maybe a 7, and not 100, but maybe say 94 or 93. And then if you add the two together and then divide, you should get to then your threshold value. You have to get the average. But what we want to get to is the PID, which is a proportional integrated line follow, and then it determines how much it sees of which color, of which reflected light intensity, and then it determines, so you don't just turn and turn, so you don't just zigzag anymore, you just kind of, and it's less of a zigzag, and I was going to say more of a zig, but it moves much more smoothly. All right, and then there's obviously information of where best to put your color sensors and your light sensors. All right, now again, your light sensor then matches up with your linear, whether it's a linear program or repetition, which is doing something, a chunk of code in that structure that Casper showed you just now, or whether you do decisions, okay, where you based on a value, whether you go left or right, you stop or go, or whatever it is like that. All right, so the objective of Unit 2 is then to attach a color sensor on a robot. Obviously, it depends on what your specific task is. All right. So there's a color sensor, and it must be rigidly attached, and it must have the correct channels to the input ports. Or if a spike prime, you must just know which ports it's attached to. All right, it's a little bit more freedom with the spike prime. Okay, so there are three lights that you can measure. The color is the rainbow spectrum. So the Roy G. Biv, with black and white as well. And then it's usually a multicolor. That's a multicolor sensor. So you can test whether you see green, yellow, or red. You can see black or blue or green. So you can test for multiple colors. It doesn't need to be one color. Okay. Whereas the ambient light is the room around you, and then the sensor is usually a dim blue, waiting for the light in the room to change. All right. If you had a robot that was working on a desk and it works until there's load shedding, and then it must stop. So as long as it's got ambient light of about 50, then it'll go. And if the light just dips, then it'll stop moving. It's the same thing. All right. And then your reflected light intensity value is then how much is reflected off the surface. Okay. And if you have a black surface, it will be definitely 0, and a white surface will be very white. So it'll be very light, and most of the light is reflected. Okay. And usually your sensor, your EV3 sensor, shines a red light for reflected light intensity. And then you can confirm that with your port view or that canvas. When you attach your robot, you can actually see what the value is that your robot color sensor is detecting. So how to attach a color sensor? Well, if you want to go forward, you can push it forward if you want to detect a color in front of you. All right, but it's usually down in front at the back, and usually not in the center like that, but usually at the left and the right wheels. And to avoid distraction, you usually build a structure around it to keep out distracting light. Okay, we have also seen color sensors mounted at the back of the robot, and that's when you reverse to find a line. Okay, so you reverse this way, you reverse that way, then you can align yourself on a line. But mostly it's going forward. All right. And then you can have it facing up. Your color sensor could be mounted facing up, and that will be detect the ambient light. Okay. Again, you do need to attach it with pins to make sure that it's rigid. It mustn't flap, and it must be maximum of probably your pinky off the surface. It can't be totally on the surface. It also can't be way up here, because then there's too much light coming in from all the sides. Okay, so it must be rigidly attached with a connector and with beams, but it must also have a port. It must be connected by a wire to a port in the brain. And I usually use color sensors on ports 1 and 2, but that's also 2 and 3, but that's also yeah, that is your convention that you can use. All right. So to detect a color, you could maybe put something in front on a white surface, and you detect the color. If you want to detect the line, if the line is very thin, your robot must move extremely slowly to find it. You can do some tests to see if you go to 50% power and your line is, say, 1 millimeter, 6 millimeters, 10 millimeters. Which one does it see? Which one does it detect how fast it goes? So that's a good experiment to do with your learners to see how it goes. The ambient light is in the room light, and it's cool to shine the light and make the robot only move when your torch is shining on it. And when you take your torch away, then the robot must stop, something like that. But that's just to get the learners to understand this is ambient light and the impact that it has on the robot and on the movement. Okay, the RLI values, the reflected light intensity value, is usually calculated with a threshold value, and it's taking the minimum and the maximum. So in the ideal world, the minimum is 0 and the maximum is 100. So together, if you add the average, or if you calculate the average, you would get a value of 50, and that then would be your threshold value. But as you move forward and as your robot gets smarter, you would definitely measure a minimum value, measure a maximum value, and then calculate a threshold value, and that will be an ongoing calculation. Okay, so here is looks like we've just done this, but it's similar. So we set the movements to B and C, and we set the movement to 50% power. So here we're going ting ting ting, and there's your color sensor. All right, it's in port number 3, and we go forward. We go forward, repeat until we see black, and when we see black, then we stop moving. Okay, so that's, you just keep going until you see black, and then you stop. All right. Oh, and this is the hamburger effect. You know, you start the robot and you must be flat at the bottom when you end the robot. It's just to make sure that the program is well constructed. Okay, so if you have a reflected light RLI value to follow on a line, let's start on the follow on the left hand side, or you can follow on the right hand side. Often we follow on the left hand side and do counts, intersection counts on the right hand side. I will demonstrate that to you tomorrow. But first things you need to get right is to follow the line on the left hand side using the zigzag, tick, 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 tick. All right, and keep it over the left wheel, and that'll give you a better chance of reading what the values are. Remember, if you're following on your line, you're going forward like this, and this is the road, and this is the white surface off the road. You're following. If you see too much black through the color sensor, then you need to go this way. So then you put your B motor off and your C motor goes. If you see too much white, then your C motor goes off and your B motor goes on, and then you go back again. So that's the zigzag that you'll see in your robot. Okay. This is a line follow, and this is again repeat until we've got the touch sensor. So until you get to a certain level. Okay. So if it's less than 50% reflected light intensity, then you set C to 20 and B to 5. Okay, so if it's black, then the B motor goes off and C motor goes on. All right, and then you go moving straight. Otherwise, you set the C motor to, you put the C motor to lower and the B motor goes up, and then you go like that. And then zigzag, zigzag, zigzag. And you keep doing that until your touch sensor is pressed. Okay. And that was from the line follow on the EV3 classroom. Okay. That's very similar.
Sorry, Dr. House. Sorry to disturb. What icon is this now? Is this an ambient light? The one with the dots? That
one over there?
Yeah, you're on your program.
That's your color sensor.
No, I see the color sensor just below, before C on your left. What is this icon for? Ambient lights.
Where?
There, yes, where your cursor is.
Yeah, that's the motor.
Is that a motor? Okay.
Yeah, that's the motor.
Oh, okay, thanks.
Okay, thanks for asking. Thank you. That's Lusanda, I think.
Yes, Dr. House.
Excellent. All right, excellent. So that's how you line follow. And now you can go faster or you can go slower, but it's a good idea to just get started and to see how you follow the line. Okay. All right, so there's a great start to some really cool references for an EV3 color sensor, how to go to a line, how to stop at a line, what are the basics, and crossing intersections is kind of next level. I would first master the following the line, and then we can cross intersections, because then you need to count how many intersections you go over. All right, and that is the end of my presentation for today. But I'm happy to answer questions, and I am realizing that we need to have a practical session, which I will then set up for tomorrow's session. We will start with a practical session with demonstrating the code and then how it is executed on the robot. Okay. And we'll get everybody else who has robots.
Yes. I do have a question, Dr. House, regarding ambient light. I just want to know, is in our programming, is there any code where you can test ambient light with your robot, or you just include or embed your ambient light with the color sensor? Like when you're doing your color sensor, you include your ambient light as well.
Can I give you an example tomorrow, Lusanda?
Oh, at what time again?
We are again meeting from 2 o'clock to 4 o'clock tomorrow.
Oh, okay. All right. Thanks.
Okay. Excellent. Thank you for that question.
Okay.
Excellent. All right. Anybody else? Anybody else? And I think we need to do a poll tomorrow also to see how many have got EV3s and how many are on spike primes already. Yeah. Anybody got any other question? Yes. Hi, Francois. How are you doing? You're welcome to unmute, Francois. Can Francois not unmute himself? Casper?
Let me try to test.
Thank you.
Okay. Try now.
No. Hallo,
Hello, Francois. Yes.
Hallo dokter. Luister, ek het net 'n vraagie in terme van want ek obviously dis iets nuut wat ons wil implementeer by ons skool. Maar ek weet die DBE het ook 'n program waar hulle hardloop met die microbits.
Yes.
Ek weet nie bewus van dit nie. Hoe gaan dit nou gebeur byvoorbeeld as dit nou 'n deel van die syllabus word en jy's deel met die first Lego challenge want die first Lego challenge lyk my onlik baie cooler as wat ons by huidige oomblik met die microbit doen. Ek weet gaan dit nie clash op 'n stadium of hoe gaan dit I mean is dit nie maar dieselfde ding nie. Julle het Unisa het die first Lego League challenge wat ook sy eie robotjies het en dan try DBE nou ook hulle ding doen met hierdie microbit. Maar hulle try nog hulle voete vind en hulle ek weet jy hulle nog ons het nog net 'n klein dis dingetjie gekry en dis al.
Okay.
Maar I mean ek verstaan. Yes, ja, probeer maar ek weet nie of ek reg die vraag vra nie.
So I've been teaching robotics for the last 14 years. To teach robotics, you require a forgiving system and you invest in equipment that teaches your learners two things. They need to learn the fundamentals of engineering. They need to build something. And two, they need to actually do the programming. So it's form and function. Robotics is about form and function, and between form and function are the development of 21st century skills. And that is the rationale, how we are encouraging our learners to learn robotics in terms of engineering and programming and developing the 21st century skills. Most of these other systems are electronics. They're not robotics, they're electronics. They're just electronics with components. They're not reusable. And so you have to invest multiple times in the year. Whereas with these kits, you invest once off. It's a forgiving system. If something is not right, you change it. You are learning and it's forgiving. All right. The first Lego League has been in existence long before the DBE came with their curriculum. That said, the DBE has a curriculum which is an evolving curriculum. It needs to be ongoing, dynamic, and introducing as many robotics to learners to as many robotics as possible. For I-SET Robotics, that has been on the go for 14 years, we use as our teaching environment, we use the EB3 robotics kit, and we use now the EB3 robotics kit has been retired, and now we use the Spike Prime robotics kit. Whatever we do, that is our learning environment. We've been using it for the last 14 years. However, that said, there is a competition on the M3, and it is open to all robotics kits, and it is open to any programming platform, and we invite any learning to happen there, and you can enter your team with any robotics kit you like into that competition. It's open for all learners to participate in a robotics competition.
En sê my, is dit nou besluit om met die Lego League te gaan? Dan moet dit is nog steeds als ekstra kurrikulêr, dan is niks in skooltyd of wat ook al is. So en sê nou my DBE kom nou met hulle ding, hulle wil tegnologie verander in hierdie programmering in, dan moet die skool dan albei hardloop of gaan jy een of die ander kan kies?
You can use the EB3 or the Spike Prime robotics kit to teach all the concepts in the curriculum. Remember, the curriculum is not linked to a robotics kit.
Okay.
The curriculum is the theory.
Okay. All right.
You can teach your and also you can teach your kids theory. You can teach your kids theory without ever having touched a robot. The same way you teach physics without ever using a computer lab. The same way you can teach biology with the learners not ever touching a specimen.
Okay.
That
Okay,
is.
dankie,
Right?
dankie.
The I will give, if you want, I have got plenty of evidence that learners do learn all the concepts and they understand all the concepts with these kids.
Okay, thank you, Doc.
You're welcome. You can use it in class. You can definitely use it in class to teach all your teaching material. And I am busy with a mapping of the two. So I will let you know as soon as I've completed that. Okay. Cool. You can have it as a classroom activity and you can have it as an extramural. But to kickstart robotics in schools, the path that we have been following for the last 14 years is robotics as an extramural. However, there are many schools that have now incorporated it into their day and to their syllabus, and learners can then take robotics as a subject. Yeah. Okay. Francois, I hope that answers your question.
That doen baie dankie, dankie.
Very welcome. If you'd like to come and meet some of the teams that I've coached over the last 14 years, you're also welcome to do that. All right. I saw there was another hand up. Let me just check here quickly. All right. Are there any other questions? I just can't see anywhere the hands are. Ay, gedorie. All right. Van Aswegen, yes. William. Vian. Hello. Can you not unmute? Miss van Aswegen? Mr. or Miss van Aswegen? Casper, can you unmute Mr. van Aswegen so he can ask his question?
I think I did, Dr. Faust.
Okay. Okay, whilst we're waiting for Mr. van Aswegen, Andre, I see you have a PE question. Is it for whether there are any other teams in Port Elizabeth? Andre? Okay, so let's see whether we can unmute some people here. Okay, Andre, you can unmute and ask your question. And then Mr. van Aswegen, you can also unmute. Yeah. Okay, I'm not sure why people are not unmuting. Casper, why is Andre, Matthias?
They are open now. Sorry, I'm having trouble unmuting myself.
No, it's no problem. No problem. Yes.
When will you guys be in PE? I would like
When
to
will we be?
visit you guys.
Hopefully soon. We're just waiting for approval for the visits.
Okay, cool. Keep me posted on the date. Thank you.
Okay, but Andre, the Nelson Mandela Bay University is running robotics as well with us.
Do you have maybe is it open any day of the week we can pop in there? Or?
Andre, if you can send me an email and then I will forward your email to Annalie.
Okay, thank you very much.
That's awesome, cool, excellent. I know that she does run robotics workshops at the university there. Yes. Okay, awesome. Thank you. Okay, so now anybody can unmute and chat. Please unmute yourself and let's have a conversation. Anybody? Okay. So just on that note, we've got quite a few universities that are also presenting robotics workshops. And we're also trying to collaborate with science centers that they present kind of practical sessions based on what we are doing here now. Yes. All right, Tsepo. Hi, Tsepo.
Good afternoon, everybody.
Good afternoon. How are you doing?
Great. I'm just curious, and I just want to ask a question regarding to the color sensors there.
Yes.
Because sometimes even myself, I'm struggling to teach the kids. Sometimes when we've put it in the right, I don't know whether we have a problem to put it in the right position or what, because sometimes it sends yes, even if it does the right programming, sometimes it sends, but sometimes it doesn't sense. I don't know what could be the problem, because I've asked the question on the chat, so I see no response.
Okay, so Tepo, we're going to start tomorrow at 2 o'clock. We're going to start with some practical examples of using color sensors. Is that okay?
Oh, okay, no problem.
Okay, and then you show us how your light sensor is, your color sensor is connected, and then we'll see whether we can give you some advice.
Okay, that will be great.
Okay,
thank you.
All right, you are very, very welcome. Okay, so we're going to do detect a line, follow a line, find a color. We'll do all those kind of examples. Hi, Liesel.
Hi, Doc. I just want to check. I might have missed it because I was a bit up and down. Are there robotic guidelines out for any of these? And is it the same as the building instructions that you mentioned not so long ago?
Yeah.
Okay, so okay, let me just mute. Tepo, just mute yourself. Okay, so Lisa, say again for the building instructions.
Yeah, I'm wondering if there's robotics guidelines out there that teaches you, because you mentioned a lot about conventions and things to be aware of. Are there standardized guidelines out, robotics guidelines that we could follow?
Okay.
And is it the same as the building instructions, or are they different?
No. So if you look under M1, you'll find an M1 overview document. That is from lessons learned, and that is us as a community engagement sharing with everybody else. So those are the lessons learned from 14 years of robotics training and coaching and lessons and workshops. All the stuff that's in there, that's the M1. That's kind of your guide. And then they are building, and M2 has also got an overview document that you can also download. M1's lesson plans, if I can get enough power tonight, I will upload the M1 lesson plans for M1 and M2 soonest. So you can use that as downloadable to guide you. Why do we use building instructions? We use building instructions because we need to create a frame of reference. Okay, so we are very aware that children have not grown up and educators don't know how to build. If I tell you now, build me a windmill, you need to have some frame of reference. So building instructions are introduced, building instructions for robots, building instructions for attachments, building instructions for powered and passive attachments, building instructions for all the sensors that you attach to your robot. They are used to build a frame of reference. Okay, the important thing is what you do with your frame of reference is you must build on that. So you must create your own designs. You must create robots in your own design. Usually when teams come to competitions, kind of the first year, we know what the designs are, the standard design. So if you come with an EV3, a Riley Rover, or you come with a driving base for a Spike Prime, that's fine for your first year, all right? What we want to see learners in their second year and their third year, they need to start to be adapting what they've learned, use that as a framework and build their own designs. They need to be able to think beyond just the building designs. But that is why you'll see in M1, we talk about building different chassis. So in the Constructopedia, you get where the motors are under the brain, where are they on the side of the brain, where the brain is up like that. The learners need to understand that there's different ways of building different kinds of robots. And so that kind of gives them the ideas of how to build robots. So you can eventually, they can they can approach a problem and know what is required and how to build the robot that will solve the problem. And that's why we introduce building instructions and model instructions. Yep. So that's why there's building objectives in each of the units for M1 and for M2. Okay.
Yeah, got it. So the how you build, because you also mentioned that it depends where you attach your parts, whether it's at the back, how it affects your programming, whether it's at the front or at the bottom.
Yes.
So when you're trying to solve your problem, you have to have also your design in mind. Your design plays a big role, because if your sensors attach at the wrong place, it might not give you the right solution, right?
Correct.
Okay.
So if I show you this robot like this, and I attach my touch sensor here, but my touch sensor is from there to here, it's not, doesn't extend over the front of my robot. So it doesn't matter how awesome my touch sensor is, it's never going to bash into anything. This is going to bash in first. So that's a design fault. If you put the touch sensor here and it only comes up until there, so no matter how fast you drive or how slow you drive or where you drive, the touch sensor is never going to be of any use to this robot. The touch sensor must be here in the front, so you can go forward and then you can collide. So the touch sensor, this is actually the front. There are your big wheels, all right? So this is the front of the robot. So you would need to put the touch sensor mounted up here, but it must extend beyond this edge. Otherwise, it's never going to touch the wall, say, for example.
So your problem solving goes beyond just your coding in essence. Okay.
Yeah.
Okay. All right. Thanks.
Okay. I see there's a yes, I will post the M1 lesson plans. So just on an I will do that, but I'm not sure how the DBE's training material for grade R to grade 3 is also available on the MOOC portal under DBE 001 and DBE 002. DBE 001 has a book that you can download, and that's for digital literacy. And DBE 002 has, for every grade and for every term, 9 lesson plans and activities that you can just download if you want to teach the curriculum. All right. The DBE curriculum from 4 to 6 and from 7 to 9 is still not approved. And once it's approved, then the teaching training material will then be developed. Okay. All right. Phew, it's been a hectic session today. All right. Liesl, I hope that answers your question.
Yeah, it did. Thank you, Doctor.
Okay, just to show you. So I had a group of boys who started robotics it feels like gazillion years ago. And let me just go fetch the robot for you. Just give me 1 minute. So I taught them on the Riley. I actually taught them on NXT initially, and then so once I taught them on the NXT, then I taught them winning design, which is another design of a robot which is introduced in M1. All right. But this team then took what I taught them for the basic design for a winning design, and then needed to build a robot that did not get stuck. So eventually, this is Mario, their robot. Okay, this is Mario. This is the design of the learners in the team. They needed to put on color sensors, but they needed to put them in the front. Okay, they have embedded touch, powered attachments, but they needed to embed them to make the robot more versatile. They needed to go rounded things because for that particular mission, it needed to go round corners. So, and then it's got a space here where you can charge the robot without having to remove the brain. Okay, so this comes from 6 seasons of problem solving, and this is where the learner's thinking must go. Their attachments, I'll show you the attachments tomorrow, are designed from what they know and what they need to do, and we'll talk about attachments tomorrow. What we're trying for our learners is they must understand the engineering principles, but they must also be able to design their own attachments moving forward. Okay. All right. Any other comments or questions? Or I think our time is up for today. We will definitely see that we have a couple of robots running around for tomorrow, so you can see how it's done. And Any other questions? Any other comments? Any other? Before the load shedding catches us. Anybody else? I'm just checking that there's no. Thank you very much. All right. Thank you for all these comments. Yes, let's take the next. Well, now we've done census. Now you've done census. Now what you need to do is practice. And Seppo, I hear you. With census, you really just need to practice. You need to practice. But let's see whether we can resolve your problems and see whether we can move forward on the because a learner with a robot with sensors, or a team of learners with sensors, just goes that much further and is that much cleverer. All right. So on that happy note, Tumelo, do you want to close the session for us?
Ladies and gentlemen, thank you so much for being part of UNISA Science Engagement Center's live online session. Today's session, as I've indicated, was M2 Unit 2. We had our Unit 1 earlier on today. Tomorrow it will be M2 Unit 3 and M2 Unit 4. Once again, for those of you who joined us, would like to take the opportunity to thank you. For those who will be watching the recording, really appreciate you. For those who have questions, kindly please send us an email on I-SET@unisa.ac.za. Without wasting time, would like to thank you, Dr. Hoos, and our team members. From UNISA Science Engagement Center, we'd like to say thank you and have a lovely day.